Okay. So next what we're going to do is we have to figure out the rejection regions. It says here that alpha equals 0.05, which means if we've got two tails, what's each one?
Negative, or 1.96.
Mm-hmm. And negative 1.96 if you use that A16, A17 chart. Because you're looking at 0.025 in each tail. All right, now we're going to do our formula. Now, something I want you to write up here. Do you see how these mu's are equal to each other? That's what the null is always that they're equal to each other. Sometimes it's less than or equal to each other or greater than or equal to each other, right? But the assumption is that they are equal to each other. So even though I wrote it like this with the x minus mu over sigma to get you used to that pattern, this is always 0 because if it's 8 and the other one's 8, then they knock each other out, you see, because this is the null right here, so it's assuming that they're equal to each other. So whatever, if this was 3,000, this would be 3,000, that would be 0. So really it's just x bar minus x bar 1 minus x bar 2 on the top that we need to worry about. The only reason I wrote it like that was so that you're used to the x bar minus mu over sigma part of it all. So really all we care about is this x bar 1, so I'm going to write 4,777 minus x bar 2, which is 4,866, divided by big square root, 1,045 squared over 250 plus 1,350 squared over 250. All right, try to put this all in your calculator at once. You getting lost on the 0 stuff?
That doesn't make sense to me, because you could have two samples that have different average mu's.
Right, but this is what is supposed to be like the null hypothesis. And the null hypothesis in this case is that they are equal to each other.
In this one, but like, what about the greater than?
If it was greater than or equal to, it is still possible that they're equal to each other. Yeah.
So you just always treat it like 0?
The mu's, yes, you treat it like 0. We're assuming that there is no difference, and then we're using this difference as our main thing. What happened? So like, suppose that it's like a weight loss drug, then your second group will be less than your first group, which you're hoping then it will go negative, right? Like we'll have weight loss. And then our control group is that the weight loss drug doesn't work. So this is like I want you to imagine this is like the test, okay?
Yep.
This is the control. And this down here is like the variance. So this is what we're testing for. Our control is assuming that nothing changes, that nothing works. Does that make more sense to you? Okay, so like imagine this is a weight loss drug. Let's say that I weighed 250 pounds before, and then I took a weight loss drug, and now I weigh 230 pounds. That's negative 20 pounds. The control is assuming this drug does nothing. It doesn't change my weight at all. And then down here is the variance, as in like how much this varies between people and whether 20 pounds is super significant or not significant at all. Like, for example, let's say I was a killer whale and I lost 20 pounds. People would be like, you don't look any different, you know? And I'd be like, oh, can't you tell? I used to be 750 pounds and now I'm 730 pounds. And people would be like, no, we cannot tell. But if I was a dog and I lost 20 pounds, yeah, you could tell. You could tell quite a bit because I used to weigh 50 pounds. Now I weigh 30 pounds, and that's pretty significant. That's a bigger variance. See what I mean? So like the killer whale would not have a very big change, even though it was still 20 pounds, because 20 pounds isn't a big deal for a killer whale, but for a dog, it would be a huge deal, and they'd have a negative score of like, a z-score of like negative 10, because they lost too much, like way too much weight, right? Where a killer whale might have a score of like negative 0.1 or something. They'd both be negative because they're losing weight, but it's not varying as much. Is this helping?
Yeah, that makes more sense.
Okay. Okay, so going back down here, you gotta try putting this in your calculator all at once. Put parentheses around the top. Parentheses 4,777 minus 4,866 parentheses divided by second square root. The nice thing about the stuff under the square root is that it actually all takes care of itself as far as order of operations, so you don't need any extra, anything. I got negative 0.82 for a z-score, which, let's see, 0 is right here, so that falls, I don't know, like here, maybe? Falls in the null. So I'm going to accept the null. And what? Reject the claim. That California and Illinois have different credit card debts. Okay. So back page. This one, do you want to try on your own? I need to give you the information still, so let's write that down first. Texas, and is Virginia VA?
Yes.
Travel agency claims that the average daily cost of meals and lodging for vacationing in Texas is less than the average daily cost of it in Virginia. Table below shows that a random survey of vacationers in each state, 2 samples are independent. Assume that sigma 1 is $19 for Texas, sigma 2 is $24 for Virginia, and both populations are normally distributed. Okay, what I think we should do is I'm gonna have you guys work together as a group of 3, talk each other through it, confirm things with each other, and then at the same time, I'm going to be doing the problem up here so you can check your work as you go. Sound good? Okay, make sure you're talking to each other.
So, once we got this, the first thing you can do is say what your z-score is gonna be.
No.
Right?
I don't know, I just pulled z-score first.
There's 2 ahead of you.